Welcome to GER Hub Mathematics and Statistics lessons. Today I'm going to be talking about the symmetric matrices and skew-symmetric matrices. Symmetric matrices and skew-symmetric matrices. Before we begin, please subscribe to our YouTube channel because it makes us grow as a channel. If you really support us and like our content, then do that by subscribing to the channel. Also help us like our videos, watch our videos, and most importantly, share our videos. That will be you supporting us. Thank you very much for your subscription so far. Thank you for yet more to come. I am very grateful. Thank you very much. Let us begin. The symmetric matrices. What is a symmetric matrix? Okay, so I'm going to start with saying that let A be a matrix. Let A be a matrix. Then A is said to be symmetric if A transpose is equal to A. Okay? So a matrix is symmetric if its transpose returns the same matrix. So I'm going to write here, if you don't want to define it this way using concrete matrix such as A, let A be a matrix, then A is said to be symmetric under what condition? When its transpose gives the matrix itself. You can define it just by statement saying a matrix A is symmetric. A matrix A is symmetric if the transpose of the matrix A gives the matrix itself. So if the transpose of A returns A as its result, then A is said to be a symmetric matrix. Why is it a symmetric matrix? It is because its transpose gives us A. So let us see an example. If I give you a matrix such as a 2 by 2 matrix, such as A equals 4 and 5 minus 3 minus 3, then take note of what its transpose will give us. The first thing you do to know if a matrix is symmetric or not is to take its transpose. So I'm going to take the transpose of A here. When you take the transpose of A, note what it gives us. It will give us, remember, for transpose, all you have to do is to take the rows and make each row in the matrix a column in the new matrix. So if the row was 4 minus 3, in the transpose of A, it will be 4 minus 3. This row will be made a column. The second row will become a second column, and that will give us this row, which was formerly 3 and minus 3 and 5, becomes minus 3 and 5. Note that you will notice that A is equal to its transpose. So what can we say about A? A is symmetric. So when the transpose of a matrix returns the matrix itself, that matrix is symmetric. Again, we can take another matrix. Let's see another matrix such as this, a 3 by 3 matrix in this case. Now if I take a 3 by 3 matrix, A or B rather equals 4, 6, and then 4, 2, and then 6, 1. Okay, and I put here 1, 6, and 6. Let's see. Then if you take a matrix such as this, note that B transpose will be equal to, making this first column or first row a column becomes 4, 6, 6. Making the second row a column in the transpose becomes 6, 4, 1. Making the third row a column becomes 6, 1, 2. Now, is there any difference between B and B transpose? You will notice that there is no difference. After transposing B, note that we still have B as B transpose. We now say since B is equal to B transpose, then B is symmetric. So if you want to know whether a matrix is symmetric or not, all you have to do is take the transpose of that matrix. I have taken a matrix A and taken its transpose. If the transpose is the same as A, then that matrix is symmetric. In this case, you will notice that the transpose of A was actually the same as that of A transpose. So that matrix was symmetric. Now, if you take a matrix B given as 4, 6, 6, 4, 6, 4, 1, 6, 1, 2 and transpose it, you end up having the same matrix. So B transpose is the same as B, therefore B is said to be symmetric. Now, let us take another example. So if we take another example of showing that a symmetric matrix, if you take another example, let's call a matrix C this. I'm going to call a matrix C 2, 1, 0, 1, 0, and I will take here 5, 3, and put here 4, and here 4. Okay? Now, this matrix, for us to tell whether this matrix is symmetric, all we have to do is to do what? Take the transpose of C. When you take the transpose of C, you will notice that this row becomes a colon. And in this matrix, it becomes 2, 1, 0. This second row will become a colon in the transpose. That will be 1, 5, 4. If this one is turned to a colon, it becomes here, it becomes 0, 4, 3. Notice that the matrix we have obtained as C transpose is the same as C. So we conclude, since C equals C transpose, then C is symmetric. Okay? C is symmetric. We can take again a matrix D. This is a matrix D, and I'm writing here minus 2, 1, 3, and minus 2. Note again, if you want to determine whether D is symmetric, then D transpose will give you the same as D. So transpose this by taking this. This will be 3 minus 2, okay, in colon. If you transpose this, this will give you minus 2 and 1. Note that D is the same, again, D is the same as D transpose. So since D is equal to D transpose, then D is symmetric. D is symmetric, full stop. Now, what if I gave you a matrix E to check whether it was symmetric or not? If you check the matrix, let me give you 3, 4, 2, 4, 1, 8, 0, 1, 5. Okay? Now, if you take the transpose of this matrix, this, let's see, you will notice that the transpose, in the transpose, this becomes a colon. So I'm going to have here 3, 4, 2. In the transpose, this row becomes the second colon, and this becomes 4, 8, 1. In the transpose of the matrix E, this third row becomes a third colon, and that becomes 1, 0, 5. Now, ask yourself the question, is E equals to E transpose? It is not. So we conclude, since E is not equal to E transpose, then E is not symmetric. E is not symmetric because it is not equal to the transpose. Okay? Now, that being said, let us go to the next type of matrix I want to talk about here, and that is skew-symmetric matrix. A skew-symmetric matrix, a skew-symmetric matrix is any matrix whose transpose is the same as the negative of the original matrix. So if the transpose of a matrix gives you the negative of the original transpose, then that matrix is skew-symmetric. So if you want to put it in very concrete form, let A be a matrix. Okay? A is said to be skew-symmetric. Under what condition? A is said to be skew-symmetric if A transpose is equal to minus A. So if A transpose is equal to minus A, then A is said to be skew-symmetric. Okay? So that being said, let us take an example. If you take the transpose of a matrix and the result you get is minus times the original matrix, then the original matrix is called a skew-symmetric matrix, simply because its transpose is equal to minus times itself. Okay, that is what we are trying to say. So it is not difficult to understand. If a matrix is given to you and you take the transpose of that matrix and notice something about the transpose, that the transpose is the same as minus times the original matrix, then that matrix, the original matrix, is called a skew-symmetric matrix. So I'm going to take an example here. Examples of skew-symmetric matrices. Skew-symmetric matrices. Okay? So, what example can we give? Let me give you a matrix A such that we have 1, 1, 1, and this is minus 5, and this is minus 6. This gives you what do you call it? Minus 5 and minus 6. So this gives you minus 5, or rather it gives you, this gives you 5, and this gives you 6, and here we have 3, and let's have 3 over here. Okay, now let's see if we have this to be minus 5 minus 6, and we have this to be 5 6 minus 3. Let's see something about what I am telling you. Now if you transpose this matrix A, you would get the transpose to be this. So let's see something about the transpose of A. I'm going to transpose this matrix, meaning that the first row will become a first column, and that will be 1 minus 5 and 3. The second row will become a second column, and that will be 5, 1 and minus 6. The third row, minus 3, 6 and 1, will become a third column, and that will be minus 3, 6 and 1. Now notice that the result we obtain is not the same as A, but if you look at it closely, you will realize that this result is the same as taking minus times A. So I'm going to put a minus sign here and then put 1 minus 5 3, which is the original matrix, and I'm going to put here 5 1 and minus 6. I'm going to put here minus 3 6 and 1. I want to check whether or not minus times the original matrix, which is A, is equal to this result we have just obtained. If it is, then the original matrix A is said to be skew-symmetric. Now check. You will notice that notice this about the result. You will notice that minus times this matrix will give us minus times 1 is minus 1. Okay, can you see that? Okay, in particular, let me put this as 0. Let me put this as 0. Let me put this as 0 to give me a better result. Okay, I want an example that shows you clearly what a skew-symmetric is, a skew-symmetric matrix is. First of all, before I show you what it is not. Okay, so let's see. If I use minus to multiply 0, this will give me 0. Can you see? If I use minus to multiply this 5, it will give me minus 5. If I use minus to multiply minus 3, to give me 3. If I use minus to multiply minus 5, it will give me plus 5. Times 3, it will give me minus 3. Times 0, it will give me 0. Times minus 6, it will give me plus 6. Times 6, it will give me minus 6. Times 0, it will give me 0. Now, notice the result. You will notice that this result is the same as the transpose. So what would you say? If the result you get, if A, so you can conclude here that if or since A, let me bring this forward. So since A equals A transpose equals minus A, then A, the original matrix, is said to be skew-symmetric. A is said to be skew-symmetric. Okay, let's take another example just in case you did not get that clearly. Let's take another example. So I'm going to take a matrix B. Okay, if I gave you a matrix B and the matrix B is a matrix like this: 0, 0, 0, minus 2, 3, minus 5, 2, minus 3, and 5. Okay, and you take this transpose, we want to check whether or not this matrix is a skew-symmetric matrix. So if you take the transpose of B, let's see what we obtain. Transposing this means that this becomes a colon, and that will be 0, minus 2, 3. Transposing it means the second row becomes a second colon, 2, 0, and minus 5. Transposing it means the third row becomes a third colon, minus 3, 5, and 0. Now, notice something. You will notice that this transpose, B transpose, is equal to minus times B. So let us check. What is minus times B? Minus times B is minus times what we are given as B, and that will be 0, minus 2, 3, 2, 0, minus 5, minus 3, 5, and 0. Now let's multiply. If minus B gives us this result, the same as the transpose, then minus B, then B, the original matrix, is said to be skew-symmetric. So let's see. Now multiply 0 by minus, it will give us 0. Multiply minus 2 by minus, it will give us plus 2. Minus times 3 will give us minus 3 for the first row. Minus times 2 gives us minus 2. Minus times 0 gives us 0. Minus times minus 5 gives us 5. Minus times minus 3 gives us plus 3. Minus times 5 gives us 5. Gives us minus 5. Minus times 0 gives us 0. Notice that this and this are the same result. So what can we say? We can therefore say that B is a skew-symmetric matrix. The matrix B is a skew-symmetric matrix. Why? That is because B transpose is equal to minus B. So what am I saying summarily? When the transpose of a matrix is equal to the negative of that matrix, then the original matrix itself is said to be skew-symmetric. But when the transpose of a matrix gives you the matrix, the original matrix itself, not minus times the original matrix, if the transpose of a matrix gives you the original matrix, that matrix is symmetric. But if the transpose gives you negative of the original matrix, it is skew-symmetric. Thank you very much for watching this video. Thank you for your subscription so far. Please do not fail to subscribe to the channel if you have not already. Thank you, and thank you.